everyone, and welcome to sVoid. I have an absolute vast amount of videos and topics in the works, but what better way to start off than with a bang? More specifically, a Big Bang. Everything we know, the galaxies, the stars, the planets, and even the atoms that make up your body, all began with one event, the Big Bang. But what exactly was the Big Bang? Was it an explosion in space? And if the universe had a beginning, what was there before it? These are questions that have puzzled scientists and philosophers alike for centuries. But thanks to modern physics, we now have some incredible insights into how our universe was born. So buckle up, because today, we're traveling back in time, way back, to the moment everything began. First, let's clear up a common misconception. The Big Bang wasn't an explosion in space. It was the rapid expansion of space itself. There was no bang in the way we usually think of it. Instead, the universe began as a tiny, infinitely dense and hot point. This is what scientists call a singularity. At this moment, all of space, time, energy, and matter were compressed into a single point smaller than an atom. Then, in an instant, space itself began expanding outward. This wasn't an explosion that sent debris flying into an already existing void. It was space itself, stretching and growing. So, if you've ever wondered where the universe is expanding into, the answer is, it's not. The universe doesn't expand into anything. It's just getting bigger everywhere at once. Let's rewind to the very first moment, the Planck Era, a time so early in the universe's history that our current physics can't fully describe what happened. This occurred within the first 10 to the negative 43 seconds after the Big Bang. At this point, the universe was unimaginably small, trillions of times smaller than an atom, and existed at temperatures of 10 to the 32nd Kelvin. That's 100 quintillion times hotter than the core of the sun. During this time, the fundamental forces of nature, gravity, electromagnetism, and the nuclear forces, were all united into a single force. But as the universe began to expand, these forces separated one by one, setting the stage for the physics that governs our universe today. Then came one of the most mind-boggling events in cosmic history, cosmic inflation. In a fraction of a second, between 10 to the negative 36 and 10 to the negative 32 seconds, the universe expanded faster than the speed of light, growing from the size of a subatomic particle to the size of a grapefruit. That might not sound big, but keep in mind, this was an entire universe expanding that fast. Now let's put that into perspective. Imagine holding a tiny dust particle in your hand. Now imagine it suddenly inflating to the size of the Milky Way in less than a second. Now that's how fast and extreme cosmic inflation was. As inflation ended, the universe was left in a hot, dense state, filled with a primordial soup of energy. Within the first 1 second, the universe had cooled enough for quarks, the fundamental building blocks of matter, to combine into protons and neutrons. Over the next few minutes, during a period known as Big Bang nucleosynthesis, these protons and neutrons began fusing into the first atomic nuclei, primarily hydrogen and helium, with tiny amounts of lithium. You know lithium, they're in your phone. This process lasted about 20 minutes and set the stage for the chemical composition of the universe as we know it. But for the next 380,000 years or so, something strange happened. Light itself couldn't escape. The universe was so dense that photons, which are particles of light, kept colliding with free electrons, bouncing around like a cosmic game of pinball. This made the universe opaque, like a thick fog covering everything. Then, After 380,000 years, something incredible happened. The universe finally cooled enough for electrons to combine with atomic nuclei, forming neutral atoms. This period is called recombination, and it allowed light to travel freely through space for the first time. Now that first light, it's actually still out there today. We call it the cosmic microwave background, or the CMB, which is a faint glow of radiation left over from the Big Bang, which we can detect in every direction. In fact, if you've ever seen static on an old television screen, a small fraction of that noise comes from this ancient radiation, meaning you've actually seen and might have heard remnants of the Big Bang on your TV. Fast forward another 100 million years, and gravity started pulling hydrogen and helium together, forming the first stars. These stars burned hot, lived fast, and exploded in massive supernovae, creating heavier elements like carbon, oxygen, and iron. These, as the building blocks of planets, life, and, well, everything. Over time, these stars grouped together, forming the first galaxies, including what would eventually become the Milky Way, which formed around 9 billion years ago. Our own sun and solar system wouldn't form until 4.6 billion years ago, roughly, meaning that by the time Earth existed, the universe had already been around for about 2/3 of its lifetime. What came before the Big Bang? 1. The cyclic universe theory. Imagine the universe like a beating heart, expanding, then collapsing, then expanding again in an endless cycle. The Big Bang might not have been the first, just the latest. Quantum fluctuations. Picture an empty, silent void, but at the tiniest scales. Energy flickers in and out of existence. Some scientists think a random quantum fluctuation could have triggered the entire universe, like a cosmic spark in the void. Third, the multiverse hypothesis. And no, I'm not talking about Marvel's Avengers. We don't talk about that anymore. Think of bubbles in a boiling pot of water. Each bubble is its own universe, popping into existence independently. Our Big Bang may have just been the moment our universe's bubble formed. Right now, these are just theories. But the more we study the cosmos, the closer we get to answering the ultimate question: where did it all begin? The story of the universe is far from over. From the formation of planets to the fate of the cosmos, we've only scratched the surface. But what do you think? Could the Big Bang be just one of many? Let me know in the comments. And don't forget to subscribe for more deep dives into the mysteries of space. You'll be hearing from me soon.